We're going to be building a Jupyter notebook on the cloud. Now this is more for personal use, but the idea here is we have our own password that we set and type and add in, and then we can create our own Python notebooks, right? So with these Python notebooks, I can go ahead and say, hello there, hit enter, and run a Jupyter notebook. And it's all in the cloud. Now there's several reasons as to why I think that you should do this. Number one, having cloud-based notebooks makes running Jupyter notebooks so much better. And I'll talk about that in a moment. But one of the reasons being, if I stop right now and go to a different computer to this IP address and log in, I can pick up right where I left off. That is huge for me for many, many reasons. I mean, sure, you could upload files, you can do a lot of things from here, but the main thing is being able to pick up right where I left off. That is pretty cool. The other thing is, if I need more resources for this Jupyter notebook. In all seriousness, I have a Windows computer to do machine learning. I bought it years ago just to do machine learning, and I bought a GPU and I set up this custom machine and all this stuff, and it wasn't cheap, right? And I did that all for machine learning, but it was a flawed idea. The reason it's flawed is because GPUs change, software changes, technology changes. So we need to be able to adapt to those changes. And this is another reason as to why you'd want to go through this one, is so you can learn how to launch your own instance that runs this Jupyter notebook. What that means is we're going to create something called an AMI. Even if you don't know what this is, it's okay. You're going to come in here, you're going to launch it. And this is where the key comes in. We can actually reconfigure or configure from scratch exactly how powerful we want our machine to run. And then we can use it for 10 seconds or an hour or 10 years and have that same capability from the get-go, which is really, really nice. So I'm going to go ahead and provision a few of these right now just to show you how easy all of this is. But the idea overall is we can rapidly launch and create Jupyter notebooks and have almost unlimited resources. And all of that is because of AWS. It makes it really, really easy to do that. So let's go ahead and provision and launch a few. And you'll be able to do all of this at the end of this series. So I have 5 new instances that I'm creating here. I'm going to add them into a VPC. It does tell me to put them in an auto-scaling group. I'm not going to do that because this is really just to show you how everything else can be done. I put them in my custom VPC, which we also cover, and then I add some storage to it. I'm going to make sure that each instance has 8 gigabytes of SSD storage, and then I'll add tags if I need. Security group is another thing that we'll cover, but it's sort of like another type of firewall that allows me to have HTTP access as well as SSH access. And then I'm going to go ahead and review and launch these. Let's make sure I've got my key pair. No worries if you don't know what that is. We'll cover that as well. And then we view these instances. So here they go. They are now pinning and loading. So it's going to take some time for them to initialize. But once they do, we'll take a look at each one. The main thing to notice here is each one of these has its own public IP address, which of course means if I grab that public IP address, I'll be able to go to it. And that of course means after it's already been provisioned. Okay, so I've let those provision and run, and now if I go to any of these IP addresses, I can go into a Jupyter notebook. And of course, it's the same password that I initially set up for each one of them, but these are now all different instances of that original Jupyter notebook. Notice that it says hello world.py, so it has some of these initial Python notebooks that I created. But they're not all sharing the same one. Like this is one of them. It has different ones, So that's really what we're going towards. And getting all this set up is just a lot of configuration. It's not really that challenging to do once you do it. And the cool thing about all this is now I can come in here, go to actions, and just terminate all of the ones that I can terminate. That is, let's unclick some of the ones that are already terminated. And I terminate all of these instances. That, of course, means several things. One of them that I won't be able to access this IP address anymore. But if I ever need to run a Jupyter notebook again, I could just spin up this AMI. All this stuff we discuss, we go in detail, we make sure that you know how to do it so you can do it at any time. Now, the long-term solution is to add other features to this than just what I'm showing you. But the short-term solution, this is pretty cool, I think. I think it's nice to be able to build a cloud-based Jupyter notebook. So let's go ahead and get started. This series is all about configuration, right? So we want to configure our AWS services to work and run a Jupyter Notebook server. Since it's about configuration, we have a step-by-step guide right here that you can check out and just go through the configuration. I recommend that you actually watch the entire series, though, to ensure that you understand what's going on with these configuration pieces, because there is a number of moving parts that you're going to want to learn about. So the first step that we need to do is actually go into Amazon Web Services, so aws.amazon.com, and create an AWS account. Now, we will be covering most of the things for free, and even if you don't go in the free tier, it's not going to be that expensive. But you do want to keep in mind that there will be additional costs associated to various things you do on AWS because it's a live running service, right? So they have a business that will charge you for using their services. No surprise there. Now, of course, if things get out of hand, just contact their support team. Especially as a student, they are very good with dealing with overcharging students. Like, one time I had a $300 bill and they just eradicated it because I was just testing stuff. And they totally understand that. They totally get it. I'm not saying that it's going to happen every time, but they understand that people want to learn their system. And that means that we have to try things out. So after you actually sign up for AWS, we are going to jump into the AWS Management Console. This is what it's going to look like after you log in. So as we've seen with the example, we want to have a server that we can access from any of our devices that is running our Jupyter Notebook. So this means that I need a server resource of some kind, right? So if you actually Googled AWS server, you'll probably find EC2. So Amazon EC2. And of course, if you went into the console itself and searched for EC2, you'll see virtual servers in the cloud. Now, this is absolutely something we want to use. But if you actually go into EC2 and you start launching an instance, so this is going to create a virtual machine for you, and you select the one we'll end up using, which is the Ubuntu server. You hit select, and we're going to use the T2 Micro. This is the free tier one. It doesn't have a lot of GPUs or CPUs rather. It doesn't have any GPUs, and it has just 1 gig of memory. So it's not a lot of resources here, but as far as setting up everything, it's perfectly acceptable. Next, the configuration. This is where we need to stop in our tracks, and it goes to this network setting where it says VPC. This right here has a default VPC. Now, we want to have our own VPC. Now, this is because of the better understanding of what a VPC is. You could go off of your default. That's probably going to work, but that means then you're going to have to sacrifice not really understanding what's going on. So keep that in mind, and that's why we're going to set up a VPC. No worries, it's actually not that complicated. There are moving pieces, and it can get complicated, but in our case, it's going to be very approachable to actually create our own custom VPC. And you want to think of a VPC as your virtual data center, right? So it's like a cloud data center. And the cool thing about this is, as an individual, you can have your own data center. I mean, it's virtual, it's not a physical location, but I think that's pretty cool. And you can do it in seconds, like awesome. So let's go ahead and do it. So we stopped in our tracks while we were creating that EC2 instance. I want to cancel out of this. I certainly don't want to do that yet because I want to create my VPC. And I want to understand what's going on. So you might actually do this step a few times, and that's perfectly okay. So let's go into our services and type out VPC. And that stands for Virtual Private Cloud. The key thing here is private cloud. So by default, it uses this concept of least privileged. So what that means is whenever you create something, it has practically no privileges or no access to do anything, right? So like in our case, we want to have it be connected to the internet. It's not going to have that by default, right? So we need to make sure that that's the case. So inside of your VPCs over here, we're going to go ahead and create a VPC, and we're going to do a name tag. Now, I think you could do all of this stuff with the launch VPC wizard. I'm not going to go on that. You can try it out and learn more about it, but I want to go from the actual scratch, which is just creating an actual VPC from the get-go, doing each step so you really understand what's going on. So we're going to go ahead and create this VPC, and we're going to get a name tag. And in my case, I'm going to call this Jupyter VPC. And now it's asking for the IP version 4 CIDR block. So what we need to do is we need to give this VPC a range of IP addresses that it should pick from. Now, I don't want to get too much in the weeds here, but the range of IP addresses has to do with how all of our devices communicate. Right? So like if you did have a data center and you did have individual physical machines, each one of those machines would have an IP address so you could, talk to it throughout that entire data center. That's sort of the idea here. And now you can actually go to CIDR.xyz to find various ranges for IP addresses that you might want. So in other words, if I did 10.0.0.0 and 16, I get 65,000 plus IP addresses to choose from. Now, AWS recommends to do this because this gives you a lot of room to grow. Even if you're doing one, it's a good idea to have this last piece being 16. And all that means is that these first parts of the bit, so this is a 32-bit number. Don't worry too much if you don't understand what I'm saying, but basically these pieces stick. Whereas if I did something like 28, then I would only have these last 4, and therefore my count is only 16. Okay, so this definitely gets into the weeds of the networking stuff that I'm not going to get into too much, but the idea is that we want to have a CIDR block or the possibility of 65,000 IP addresses for our virtual private server. Literally 65,000 possibilities. That's pretty cool. I mean, we're not paying for that either. This part is all free, which is really nice. So we do 10.0.0.0/16. And this is for our entire VPC. It's not for one part of it. It's for the whole thing. So once we actually spin up a server, it's only going to take one of those IP addresses. It's not going to take up any more than that. I'm not going to make an IPv6. You don't need to do that. You can if you wanted to, but it's not necessary at this point in time. And I believe you could always add this later if you needed it. Tenancy, we're going to leave default. We don't need a dedicated VPC. That starts to add up as far as cost is concerned. So we'll use the default. And there we go. We actually created our virtual private cloud. We made our first one. And we added some IP addresses in there, or a block of IP addresses. Pretty cool. What do we do with this? Well, let's go back into EC2. And we're going to go ahead and launch another instance. And we'll use that Ubuntu server again. And I'm using 18.04 LTS. We'll hit select. We'll do the micro again. We'll go to next, configure instance details. And we'll go to that network and grab our VPC. Oh no, subnets are not found. I knew this was going to happen, but the point is now we have to do that next configuration. And this is often how you'll learn what things are required and what things you need to implement. Yet again, we were stopped in our tracks while we were creating our EC2 instance. This time, of course, is related to our subnets. Now, what a subnet allows for us is essentially firewalls, right? So if you had a data center, you would set up firewalls. In the case of a cloud, we set up something called a subnet, and it allows for our connections to be limited or unlimited, depending on how we want it set up. Now, what that means is that we need to create a subnet, and we need to add a internet connection. Now, AWS has this concept of the least privileged, right? So when we create new things, they don't have any privileges, or they have very few privileges by default. So subnets are no different than that. We're going to go ahead and create a brand new one. You can just select create new subnet and it will actually open it up for you. Or you can navigate to the VPC dashboard and then click subnets over here. And we're going to go ahead and create a subnet. In this case, I'll call it the Jupyter public subnet. Right? So what I want to do is I want to make sure that my EC2 instance has accessibility to the internet. Right? I need to set up a few things to get there, but this is a public subnet. So that means that my resources inside of this subnet, which when I say resources, I mean literally my EC2 instance or instances, because I can have a lot of them. As soon as I put them in this public subnet, they will have access to the internet, meaning the internet can access that instance, and that instance can also access the internet too. So it can go both ways. This is opposed to a private subnet. So let's say, for instance, you're building a MySQL database. You'd probably put that into a private subnet and connect it otherwise. I'm not going to get into that too much here, but the idea is we want this to be accessible to the internet. Next, we want to actually grab our VPC. Notice that the name of the VPC is right there. I still have that default VPC too. I can also just type out and search for the one that I created, and it will actually show me that too. It's really nice, just a nice little shortcut. The next thing is the availability zones. This has to do with something called high availability. You can have a preference if you'd like, or you can leave no preference. I'm going to go ahead and give a preference. Notice that mine says US East 1A. Now, this is where you may be in a different region than me. So if you are in a different region, stop right now, switch into the same region I'm in, which is North Virginia, also known as US East 1. You're going to stop right now, go into North Virginia, create a new VPC inside of North Virginia, and come back to where we are here. Now, why didn't I have you do that in the last step? Well, the reason being is you should get very comfortable with creating a VPC and subnet. So if you have to start over from scratch several times, please do it. It's really important for your learning process. So now, a subnet itself is a smaller network of your resources. In our case, the resources are EC2 instances. So what that means is we need to create IP addresses for a smaller amount than what we had by default. So I certainly can use all of those resources, right? But it's a subnet. I want to make it smaller than all of those resources. So going into our CIDR block, we can use something like 28, and that gives me a count of 16 potential IP addresses, right? That is a lot smaller than what it was. And I can also set something like 1 here and use this for my first subnet, and then use 2 for my second, 3 for my fourth, and so on. Like I can keep changing these numbers to have different ranges of IP addresses, but they are a lot smaller than the major one, which was, when we did something like that, or rather not 14, but 16, right? So I realize that might be a little bit complicated, but the idea here is I want to make sure that this is 28, and I'm going to put a 1 at this portion here. This allows me to have this subnet only having 16 IP addresses, or so only 16 potential IP addresses being assigned to it. So I'm going to go ahead and create that. And now we have our first subnet, and it's inside of this VPC. So if we go back into that EC2, we can configuration, we can refresh in here, and we can see that now I have my VPC and I've got my subnet here. I just told you that we would have 16 IP addresses, but it only says 11 available. AWS actually reserves 5 IP addresses for a whole variety of things I'm not going to get into, but we only actually have 11 available in this, subnet at this point now. Okay, so we're not quite done with subnets though. What we need to do is ensure that these subnets have the availability to connect to the internet. So before I even configure the remaining part of this EC2 instance, I want to go back into my VPC dashboard. So now we have a VPC, we have a subnet, we can go ahead and start launching our EC2 instance. I'm going to go ahead and select the Ubuntu server, hit select, T2 micro, do next, grab our VPC, and then we've got our subnet here. And then we have this setting that says auto assign public IP, and it's using the subnet setting. Now, I actually didn't set this anywhere, right? I haven't done that yet. So what I need my EC2 to have working is an actual public IP address. So it needs to happen automatically, right? So I can say enable here, or I can go with the subnet setting, which is the preferred method here. So the subnet setting, we need to update. So jumping in to my subnet settings, I can just open a new console here, go into VPC, and go into my subnets, find the subnet I'm using, which of course is my Jupyter public subnet, click on actions, and then modify auto assign public IPv4 addresses. We're going to check that and hit save. Okay, so now we have the ability to have a public IP address. So it feels like we're done, right? It feels like, hey, I have a network, I have a VPC, I have a subnet, and I can actually assign public IP addresses, which means that if I launch this instance, I should be able to get an IP address that I can actually go to. So let's go ahead and actually launch the instance. I'm going to go ahead and click that launch button, right? So review and launch, and then we hit launch. You're going to want to create a brand new pair, a key pair here. No worries. I'm going to go ahead and just say delete this, and we'll do download key pair. We'll cover this later, and then I'll just go ahead and launch this instance. So it's going to launch. We're going to go to view instances, and we should see our actual instance come up here. It might take a minute. It's pending, and now I've got this public IP. I'm going to go ahead and copy that and paste it in to my browser and go here. And I want to actually connect to this. But actually what's going to happen is it's going to try and connect forever. Even if the instance state was ready, which it's currently not, it's just going to continuously try to connect to it, but it's going to time out. Now, the reason for this has to do with how we set up our subnet and our VPC. Remember the concept of least privilege. Right now, our subnet has no public privileges. There's no way for a subnet to actually get to this public IP address. They don't connect to the internet right now. And of course, if you were following along in the guide, you'll know I skipped a couple steps. But the idea here is, by default, our subnets do not have access to the internet, so we need to actually make sure that they can. I'm going to go ahead and pause while this finishes creating, but really all I'm going to do is delete this instance. After a couple of minutes, my instance state turned to running, and now I can go back again to that browser and that IP address, and sure enough, it's going to just continue running, right? It's going to time out. I'm not going to do that. But instead what I'm going to do is I'm going to go ahead and delete this instance. So we go into select the instance itself, go to actions, instance state, and terminate. So this will terminate all of the things associated to this instance. It might take a minute to actually terminate it, and it will shut down. It takes a little bit of time to actually do all of those things. But this is a habit you want to get into. You want to definitely get into using and destroying instances as you may need, right? And then I'm also going to go into key pairs down here on the bottom left, and I'm going to delete these two key pairs. Now, if you don't know what you're doing here, you probably don't want to delete them. But in my case, I know exactly what I'm doing. I don't need those key pairs. I want to start sort of from scratch. So I'm also going to go into my VPC dashboard and go into my VPCs, and I'm going to delete everything here as well. Now, of course, you don't have to do this, but I'm doing it because I want to make sure I'm setting everything up right from scratch, and essentially now I'm starting from zero. So now back into the AWS Management Console, we're going to go into EC2, and we're going to provision our first EC2 instance. Well, I guess it's not technically our first, but it's the first one we'll actually work with. So I'll go ahead and launch instance, and I'm going to be using an Ubuntu server. I have some different scripts to set up an Ubuntu server, which is why I'm using it. You can probably use these other servers as well. It doesn't actually matter what you end up using, but the scripts to setting up, I found that this Ubuntu server is a really nice fit for that. So Ubuntu server 18.0.4, and we hit select, and we go to the T2 Micro. So this is a free tier. That's the reason we're doing this. If you actually wanted to start using Jupyter at a little bit of a higher level, you would probably want to use the T2 instance, or you would want to actually go and get GPUs as well. It's a little bit more advanced than what we're going to do here, so I'll stick with that T2 Micro instance. Next, we're going to go ahead and configure it. No surprises here. We're going to change our network to our Jupyter VPC. We're going to use that subnet, and I'm also going to auto assign that public IP, just as we saw before. But now what I'm going to do is I'm going to scroll down to advanced details. Advanced details allow me to run a bootstrap script or a startup script. So when I start this instance, it's going to run what this script is. Now, what I want to do here is I want to actually put in what's in this post here. So in the post under provision and EC2 instance, you scroll down and we've got all sorts of installations here. So I'm going to go ahead and copy those and we're going to paste it in here. Now, I'll just briefly go over what's going on here. And let's scroll down a little bit. It's a bash script, so we need to declare that it's a bash script. It's going to update our server right off the bat. It's going to install some essential builds. It's going to install something called Supervisor, so we can have different processes running, which we'll see in a little bit. It's going to install Python 3 or ensure that Python 3 is installed. I believe it installs 3.6, but that version doesn't actually matter so much unless you need a different version of Python. And then some other sort of related services that we need, like Git and Nano, and then also Nginx. It also installs another firewall. So this isn't actually necessary because of something that we have yet to talk about, but it is there, and it's nice to know that even on my EC2 instance, I can add another layer of security. We already have a lot of layers of security, but this is going to add in another layer to make sure my web server of Nginx runs and works correctly, as well as the ability to SSH. And then finally, we install Jupyter, and then we start our supervisor service. Again, we'll go over a lot of this stuff once we actually SSH into our server, but it's nice to know that I can have this script and have it launch right off the bat. I'll go ahead and hit next, add storage. This is how big you want your SSD on your server to be. 8 gigabytes is plenty for what we're doing. You can absolutely make it bigger. I think if you're going to start making it huge, and when I say huge, I mean like maybe more than 32 gigs, you probably want to use something like S3 or a very other services that allow you to have different kinds of storage. I'm not going to get into that right now, so we'll just stick with 8. Next, we can add tags if we want them. I'm not going to add tags. And then finally, we're going to add a security group. So remember when I was saying about firewalls, this is another way of doing security. So we're going to go ahead and create a brand new one. Notice that by default, the only thing that you can do into this instance, regardless of what's going on with the VPC, the only thing that you can do in this instance is SSH. When I say regardless, the VPC means that it will have its own permissions as well. So the VPC is the top level security, right? So if I change the access to the internet on the VPC, this stuff doesn't matter. This is just another layer of security for me, which is nice for many different reasons. One of them being that I can add HTTP. And again, this is only on this instance. It's not on the entire network. So HTTP, and we could also add, HTTPS. So we can do the HTTP service, so like just a general website or a secure website with HTTPS. And then I also want to have SSH so I can actually log in. So secure shell here. And then notice the sources here. We've got the allow all for the internet access, or all IP addresses can access this instance. And then the latter part one is for IPv4, or rather 6. So the first one is for IPv4. The second one is for IPv6. The security group, we're going to name it, and I'll call this my Jupyter SG, as in my Jupyter security group, and we'll call it just like that. I'll hit review and launch, and we can review everything that's going on here. Notice our security groups have a HTTP and HTTPS for the various IPs, and I can SSH into it. That's great. Other details, if you want to go through them, they're all there. Cool. So I'm going to go ahead and hit launch, and now it's asking me for a key pair. Now this is important for when we SSH into our server. Now if you don't know what SSH is, no worries. We will talk about it once we get there. But we're going to go ahead and create a new pair here. And I'm just going to call this my Jupyter key. You could call it your Jupyter key pair, or you can, I mean, it doesn't actually matter what you call it here. It just matters that you know how to get to it. And that's usually the case when you name stuff. With the exception of those IP addresses, you don't really have to worry too much about the names that you put in. All right, so we're going to go ahead and download that Jupyter key, and I'll go ahead and hit launch instances. So there's a couple things that's going to happen here. If I go to view instances, I see my old one that I terminated, and I'm also seeing the one that's being created. Now, keep in mind that it's creating this instance, but it's also going to be running the installation process that we set up, those bootstrap scripts. So it might take a few minutes to actually initialize this instance, and it might take a little bit longer than normal because of those bootstrap scripts. But something I should be able to see now is a public IP. If you don't have this, you did something incorrect in our setup process. And I can go into this IP. If I hit enter, it's not quite set up yet. It's not quite running yet, but it will shortly. Notice that it's not pending though. It's just refusing the connection, right? So it wasn't loading like it did before. So if I copy this, and let's just use a different number at the end here, like a 7. Notice that it's just going to time out. Where this one, it just says it can't be reached. That's pretty cool. But what I'm going to do is I'm going to let it finish initializing. So I'm going to pause the video and then take a look. And so it's still initializing. And while it does, the reason that I know this is working, another reason is the fact that it refuses it right away. That's a good sign. It doesn't time out. And what's happening right now is it's actually installing Nginx. Nginx is going to allow us to have our web server actually running, which is what we'll end up using to have our Jupyter notebook actually running through. Like Nginx is needed to make sure that Jupyter runs, and now it's done. So I think it's safe to assume that if I go to this IP address and refresh it, I should see an Nginx page. Let's refresh it, and there you go. It says, welcome to Nginx. So this means that everything was set up correctly. It is ready to be configured now for Jupyter. Now, if you weren't able to get here, check out the guide and go through each step to make sure that all of those pieces are there, right? So like you want to go through all of this, but you also want to make sure that your VPC was set up correctly. And then of course, making sure that you had in your security group that you added these rules, the HTTP rule and the HTTPS rule. We didn't have to change anything in those rules. They were done by default. But if you don't see this, then you absolutely want to go back. And if you have to delete everything and start from scratch, that's completely okay. That is something that I've had to do a lot, even just to get to this point, to show you how it's done. So it's definitely worthwhile doing. So now back into the AWS Management Console, we're going to go into EC2, and we're going to provision our first EC2 instance. Well, I guess it's not technically our first, but it's the first one we'll actually work with. So I'll go ahead and launch instance, and I'm going to be using an Ubuntu server. I have some different scripts to set up an Ubuntu server, which is why I'm using it. You can probably use these other servers as well. It doesn't actually matter what you end up using, but the scripts to setting up, I found that this Ubuntu server is a really nice fit for that. So Ubuntu server 18.0.4, and we hit select, and we go to the T2 Micro. So this is a free tier. That's the reason we're doing this. If you actually wanted to start using Jupyter at a little bit of a higher level, you would probably want to use the T2 instance, or you would want to actually go and get GPUs as well. It's a little bit more advanced than what we're going to do here. So I'll stick with that T2 Micro instance. Next, we're going to go ahead and configure it. No surprises here. We're going to change our network to our Jupyter VPC. We're going to use that subnet, and I'm also going to auto assign that public IP, just as we saw before. But now what I'm going to do is I'm going to scroll down to advanced details. Advanced details allow me to run a bootstrap script or a startup script. So when I start this instance, it's going to run what this script is. Now, what I want to do here is I want to actually put in what's in this post here. So in the post under provision and EC2 instance, you scroll down and we've got all sorts of installations here. So I'm going to go ahead and copy those and we're going to paste it in here. Now, I'll just briefly go over what's going on here. And let's scroll down a little bit. We've got, it's a bash script, so we need to declare that it's a bash script. It's going to update our server right off the bat. It's going to install some essential builds. It's going to install something called Supervisor, so we can have different processes running, which we'll see in a little bit. It's going to install Python 3 or ensure that Python 3 is installed. I believe it installs 3.6, but that version doesn't actually matter so much unless you need a different version of Python. And then some other sort of related services that we need, like Git and Nano, and then also Nginx. It also installs another firewall. So this isn't actually necessary because of something that we have yet to talk about, but it is there, and it's nice to know that even on my EC2 instance, I can add another layer of security. We already have a lot of layers of security, but this is going to add in another layer to make sure my web server of Nginx runs and works correctly, as well as the ability to SSH. And then finally, we install Jupyter, and then we start our supervisor service. Again, we'll go over a lot of this stuff once we actually SSH into our server, but it's nice to know that I can have this script and have it launch right off the bat. I'll go ahead and hit next, add storage. This is how big you want your SSD on your server to be. 8 gigabytes is plenty for what we're doing. You can absolutely make it bigger. I think if you're going to start making it huge, and when I say huge, I mean like maybe more than 32 gigs, you probably want to use something like S3 or a very other services that allow you to have different kinds of storage. I'm not going to get into that right now, so we'll just stick with 8. Next, we can add tags if we want them. I'm not going to add tags. And then finally, we're going to add a security group. So remember when I was saying about firewalls, this is another way of doing security. So we're going to go ahead and create a brand new one. Notice that by default, the only thing that you can do into this instance, regardless of what's going on with the VPC, the only thing that you can do in this instance is SSH. When I say regardless, the VPC means that it will have its own permissions as well. So the VPC is the top level security, right? So if I change the access to the internet on the VPC, this stuff doesn't matter. This is just another layer of security for me, which is nice for many different reasons. One of them being that I can add HTTP. And again, this is only on this instance. It's not on the entire network. So HTTP, and we could also add, HTTPS. So we can do the HTTP service, so like just a general website or a secure website with HTTPS. And then I also want to have SSH so I can actually log in. So secure shell here. And then notice the sources here. We've got the allow all for the internet access, or all IP addresses can access this instance. And then the latter part one is for IPv4, or rather 6. So the first one is for IPv4. The second one is for IPv6. The security group, we're going to name it, and I'll call this my Jupyter SG, as in my Jupyter security group, and we'll call it just like that. I'll hit review and launch, and we can review everything that's going on here. Notice our security groups have a HTTP and HTTPS for the various IPs, and I can SSH into it. That's great. Other details, if you want to go through them, they're all there. Cool. So I'm going to go ahead and hit launch, and now it's asking me for a key pair. Now, this is important for when we SSH into our server. Now, if you don't know what SSH is, no worries. We will talk about it once we get there. But we're going to go ahead and create a new pair here. And I'm just going to call this my Jupyter key. You could call it your Jupyter key pair, or you can, I mean, it doesn't actually matter what you call it here. It just matters that you know how to get to it. And that's usually the case when you name stuff. With the exception of those IP addresses, you don't really have to worry too much about the names that you put in. All right, so we're going to go ahead and download that Jupyter key, and I'll go ahead and hit launch instances. So there's a couple things that's going to happen here. If I go to view instances, I see my old one that I terminated, and I'm also seeing the one that's being created. Now, keep in mind that it's creating this instance, but it's also going to be running the installation process that we set up, those bootstrap scripts. So it might take a few minutes to actually initialize this instance, and it might take a little bit longer than normal because of those bootstrap scripts. But something I should be able to see now is a public IP. If you don't have this, you did something incorrect in our setup process. And I can go into this IP. If I hit enter, it's not quite set up yet. It's not quite running yet, but it will shortly. Notice that it's not pending though. It's just refusing the connection, right? So it wasn't loading like it did before. So if I copy this and let's just use a different number at the end here, like a 7, notice that it's just going to time out. Where this one, it just says it can't be reached. That's pretty cool. But what I'm going to do is I'm going to let it finish initializing. So I'm going to pause the video and then take a look. And so it's still initializing. And while it does, the reason that I know this is working, another reason is the fact that it refuses it right away. That's a good sign. It doesn't time out. And what's happening right now is it's actually installing Nginx. Nginx is going to allow us to have our web server actually running, which is what we'll end up using to have our Jupyter notebook actually running through. Like Nginx is needed to make sure that Jupyter runs, and now it's done. So I think it's safe to assume that if I go to this IP address and refresh it, I should see an Nginx page. Let's refresh it, and there you go. It says welcome to Nginx. So this means that everything was set up correctly. It is ready to be configured now for Jupyter. Now, if you weren't able to get here, check out the guide and go through each step to make sure that all of those pieces are there, right? So like you want to go through all of this, but you also want to make sure that your VPC was set up correctly. And then of course, making sure that you had in your security group that you added these rules, the HTTP rule and the HTTPS rule. We didn't have to change anything in those rules. They were done by default. But if you don't see this, then you absolutely want to go back. And if you have to delete everything and start from scratch, that's completely okay. That is something that I've had to do a lot, even just to get to this point, to show you how it's done. So it's definitely worthwhile doing. Our EC2 instance is now provisioned. So it's time to actually get our Jupyter server working. And we're going to do this by using a secure shell, and that's called SSH. And we're going to use the terminal application to do this because I'm on a Mac. If you're on a Linux, you could also use terminal. If you're on a Windows, you'll use PowerShell. Now we can do SSH into this EC2 for a couple reasons. One of them being our security group allows for it. The other one is our VPC has an internet gateway that also allows for it. But our security group allows specifically for SSH to happen. Right, so if I didn't have SSH on here, I would probably not be able to actually go into this SSH for this particular security group and this particular instance. I mean, as you might imagine, there's a lot of different security measures in place. And when we created this instance, we also got some key pairs, right? So we had our Jupyter key that we created and downloaded. So you should have that in your download folder, something like this, right? So what I'm going to do is open up my terminal, and I'm just going to type out Command Spacebar and then terminal. That's just a shortcut to get there. And I'm going to cd into my dev folder, and I'm going to make a directory here, and I'm going to call this Jupyter_server. You can call it whatever you like. I'm just going to call it that, and then we'll cd into that Jupyter server. If you're on PowerShell, you just have to use these as two different commands. I just chained them together. Okay, so now that I'm in here, I'm going to go and open this up. And I'm going to bring in that private key. So bring that over, and close out the downloads. So now back in our terminal, if I list things out, I should see that private key in there. So we want to use this to actually SSH. In order for us to use it, we have to use chomod 400 and Jupyter key.pim. This just gives us our system permission to use this private key to actually run our SSH. So the command for it is SSH, and then the user in our case is going to be Ubuntu @ and the Ubuntu is the name of our AMI. Now, in some cases, you might see EC2-user @ but for our Ubuntu AMI, we use Ubuntu @. So what the heck, what's an AMI? I'm a little confused. Well, when we launched our instance, we chose an AMI or an Amazon machine image. So if you were using the Amazon Linux 2 AMI, you would use that EC2 user. But if you're using Ubuntu, you use Ubuntu @. And then we need to get our IP address, which in my case, it's this one right here. Now, if you just copy that one, it's going to, from Chrome or from your browser, it's probably going to actually give you the whole thing, including HTTP. So I'm going to go ahead and grab the instance, go there and grab this public IP, copy that, paste it in there. And then we're going to just do -I and then our Jupyter key here. I hit enter. I want to say that this is okay, this fingerprint or this host is okay for me to SSH into. We say yes, and then it adds it, and now I'm in. Okay, so if you weren't in here, that means that you are going to have to, kind of backtrack quite a bit. Like if you can't actually log in, that's a problem for sure. Notice that we have an IP address inside of our network. So this is our network's IP address for this particular instance, and it's based off of that subnet. No surprises here, hopefully. And this is now where we're going to go ahead and double check all of our installations. So back into this guide, down into the provision, the Jupyter server, I'm going to go ahead and copy all of our installations and just literally run through them again. Now, I probably don't have to do this, right? It's probably ready to go. But the reason I am doing it is to just make sure that it is done, because all of those things are requirements for going forward. Now, you should see a bunch of things like it's already installed or it's already been done. That's a good sign. That means that our Bootstrap script definitely worked. Pretty cool. Okay, so now that we've got a lot of that installation, we need to move to the next step. Now, naturally, sometimes you'll close terminal or your SSH and you need to get back to where you were. So the first thing I need to do is cd into my dev folder, cd into my Jupyter server, and I see my private key here. Now, if I'm working on a secure device like I am, like this computer that I'm working on is mine. I don't have any worries of somebody taking it or logging into my user account and stuff like that. So I feel very confident that I can make a file called connect.sh. This file is going to do my SSH for me. So it's Ubuntu @ and then we need to get that IP address again. Luckily, I still have my EC2 Instance dashboard still up. Grab that IP address there, -I, and then we do Jupyter key.pim. I believe that's the name of it. We hit Control-X, Y, Enter to save it. And then I just do chomod +X connect.sh, and now I can do just .connect.sh. Now, the reason I do that is just so I don't have to remember the IP address or log into the console every time I need to go and get that IP address. Again, you only want to do this if you're sure that your private key is secure. And you probably also want to make sure that your private key is secure anyway. But if you don't know if your private key is going to be secure, you probably don't want to have your IP address easily accessible like I just did. Just keep that in mind when you are working in developing in these different systems. So let's clear everything out. You can type out clear, and I'm going to go ahead and check that Jupyter is a command. Right? I don't have an error. Like if I typed out ABC, it says command not found. Right? So I want to make sure that that's the case. The next thing I want to do is generate my Jupyter configuration file. Now, this configuration file could have been done in the Bootstrap script. In fact, all of the configuration could have been done in the Bootstrap script. I didn't do it that way because I think this portion is useful to understand what's going on line by line and doing it together. So let's go ahead and do Jupyter notebook -- generate - config. We hit enter. And I already generated this. I'm just going to overwrite the one that's there. And this is the location to it. This is a pretty standard location. Okay. So I want to be able to edit this, and I'm going to go ahead and just do nano and then jump in there. Okay. Now going back into that blog post, we see that we want to get our public IP address. This is a way to actually grab that public IP address to inside of an EC2 instance. Using this endpoint, you can get a lot of metadata and actually grab the IP address. I don't need to know what that IP address is that way because I have it in my console. But it is nice to know that there is another way to grab it. That's kind of the point that that's there. The next, we need to actually create our default password. So let's actually close out of that nano with Control X. And I'm going to go ahead and use IPython to call a command. So IPython -command, we're going to import our notebook related stuff, and then we're just going to go ahead and call the password generation. So what this does is it's just a command so we can enter a password. In my case, I'm using a whatever password, but I want to remember what this password is. This is going to be what I'll actually log into my Jupyter notebook with once it's finally deployed. And notice this output here, this is the password that we'll end up using. So let's go ahead and copy that, and we'll go back into that config that I had. And I'm going to just add this in here as c.notebookapp.password equaling to that Unix, or the Unicode string rather. So yeah, I actually have it referenced right here. That was, how easy it was for me. But now what I want to do is actually get the rest of this stuff. So I'm going to go ahead and copy this. You can click the button to copy it too. And I'll paste it right below this password. And I will actually move the c.getConfig above here. So c.get_config, just like that. And we'll get rid of this version. The next thing is our allow origin here. So I need to put in my public IP address here. So that is critical. If you don't put in the correct one here, then Jupyter is not going to work. It's not going to work correctly, and it shouldn't work at all. So back in, we paste that in there. Now you can put a star here and allow all origins. In other words, you could, if you did that, that means that any website would have access to control your project potentially. So we just want to have one origin, and that's going to be our IP address there. And then I deleted that old password holder that was there. And then 888 is the default port. I'll just leave it as that. And I also don't want to open the browser. That's true. And I certainly want to allow remote access so that my server can run it as well. So that's all we have to do for the configuration. And the nice thing is that's all referenced here. I do have if you were to actually bring in HTTPS and Let's Encrypt, you can go ahead and change these to the Let's Encrypt stuff. So if you wanted this to be HTTPS, that would be another configuration that you could absolutely do. Next up, we have to do our Nginx stuff. But before I do that, I'm going to go ahead and run Jupyter Notebook here. Okay, so I've got my Jupyter Notebook running. And what I'm going to try and do is actually go to it on my Nginx server or my live server with 888. Now, this should actually time out. There's a reason for this, and that's because in our security group, if we go to it, we do not have a port range for 8888. So if I edit this, add a new rule, a custom TCP rule, and add 8888, and then also add the IP, so any IP there, and hit save, I should be able to refresh, or it actually does it for me. And what do you know? Our Jupyter server is running on that port. Now, I don't actually want that to happen by default, and I also don't want to have to make sure that my command is running here. And that's why we need to do those next few steps. So basically, I don't want to have to SSH into my server every single time I want to run this Jupyter Notebook. Instead, all I want to be able to do is just start my instance, just start it. And then once it's started and running, then I just go to that IP address and then boom, I'm in. That's actually what I want to have happen. So let's go back into that security group and get rid of that rule. So the 888 rule, we don't want it. I hit save, and if I refresh in here, it's going to time out. This is awesome. That is showing you how simple it is to manage security with AWS, regardless of what's going on with the instance itself. So looking back at our server, we see that port 8888 is no longer active, and it's just going to load and eventually time out. So what we want to do is we want to change this default Nginx page that's on the root of our server. We want that to actually run our Jupyter Notebook. Now this is going to take some configuration, and usually with configuration, it's a lot better to copy and paste than to tediously type everything out. But I want to show you what's going on here and how you might use this in the future still. So the first thing is, make sure that you are still SSH'd into your actual EC2 instance. I still am, right? I can list everything out, and I'm in the root of this user, okay? So I'm going to go ahead and do cd etc nginx. Now, we installed Nginx ensured it was installed in two places. One was that verify install, and the other one was the actual bootstrap when we started up that EC2 instance. That's why this directory even exists. If we didn't do that, Nginx directory would not be here. So if we list everything out, we see all of the various things that Nginx has by default. The one that concerns us right now is this sites available directory. We have one called default. So default is this right here. Right? That's the default Nginx page. It's just showing you that it works. So we need to create our configuration for our Jupyter project right here in this default. And that's what this command starts to do. It just says, hey, go to this location right here and create a new file, which in my case, I just arbitrarily called it Jupyter_app.conf. You could leave no extension on there and it will still work. But it's essentially just a text file. It's a configuration file that our Nginx our Nginx process is actually going to use. So we go ahead and hit enter here, and I'll copy this whole thing and paste it in. Now, a couple things to know. See that it says listen 80. Listen 80 means that's listening on port 80. Going back in our EC2 instance, we see that HTTP is on port 80, right? HTTPS is 443, right? So 443. We don't have HTTPS activated here. We just have HTTP. So it's not secure. And of course, it would be better if it was secure, but that's a little bit more advanced. So I'm not going to cover it at this point. So it's listening to that port. It gives us a server name. This server name would be your domain name if you were to add a custom domain name. Next, we just essentially just pass this off as a localhost proxy. So I can actually run my Jupyter server and notice that that port's there. It's going to go based off of that port. So if I used a different port for that Jupyter configuration, I would need to change that here. All of these other things are related to just ensuring that Jupyter is running and it's running correctly. You can look the docs up to see exactly what's going on here, but these are just configuration items that need to happen for our Jupyter server to run via Nginx. Okay, so now that we've got that, let's close it out. We'll say yes. So I hit Control X to start the writing process, Y to accept what I'm doing, and then Enter to have it as the file name that I started with. So now if I list it out, I see that I've got my file in there. But we're not quite done yet. All right, so going back into what we have in here is we want to actually link this file into the sites enabled directory. So if we cd back and cd into sites enabled, we see that default is in here as well. default is symbolically linked in here. It's not, the actual file is not in here. The actual file is in sites available, as I said before, or I showed you before. Now, the reason we don't just jump into sites enabled is best practices. It's much better practice to put your sites available first, and that's where you put your configuration, and then you link it into the sites enabled. But the first thing I need to do is remove the default. I no longer need that. So I'll just do sudo remove default. Sudo means, hey, super user command, remove this default. Like if you get this permission denied, you just put sudo in front of it. It'll probably do it. So now I list everything out. It's nothing. And if I refresh on my page here, it doesn't seem like anything happened. So I can actually do sudo systemctl and reload Nginx. If I do that and refresh, now I don't have anything on my actual server, right? No surprise here because I have no sites enabled. So what I need to do is actually have a site enabled. So going back into this project here, I can use this command to actually symbolically link that first file, which is right here, to the sites enabled. So the source and then the destination is next. And it's just paths that I worked out on my own for you. You just do ln dash lowercase s, not capitalized, but lowercase s, hit enter. And now we have our sites enabled. There's another systemctl command or system control command I need to do. So we do sudo systemctl daemon reload. This makes sure that Nginx knows about this file and knows that it's able to be used. It's just, it's possible that we don't need to write that, but it's a good practice to get into whenever you add files and you need your entire system to know about it or processes in your system, which in my case, the process is Nginx. So then we just do sudo systemctl reload Nginx. And now again, it's still not going to show me anything except now it says bad gateway, right? So this is actually a good sign. This means that Nginx is running, except my actual project is not running. So let's cd into the root with cd /, and we just do Jupyter notebook, hit enter. So again, I have it running again, and it's looking at my local host, right? So this is actually my local host. It's either using the IP address for my network server or the standard local host IP address. And then we refresh in Nginx. What do you know? It's actually running. That's great, but I still had to SSH in and run Jupyter Notebook. That is not what I want. And do note that it is saying that, hey, it's listening on all IP addresses and it's not using encryption. This is partially because we're not using HTTPS. I mean, that's pretty much the main reason. And it's also partially because we are allowing an HTTP connection to come through. That's why it's saying it's not recommended. But in our case, this is fine because we're only going to spin this up when we need it, and then we're going to take it down when we don't need it. It's okay in the short term. In the long term, you probably wouldn't want to do this. Now, I kept referencing how I don't want to have to SSH into my server and run Jupyter Notebook. Like I never want to do that, right? What I want to have happen is that run in the background on its own. And the way you do this is by using Supervisor D, also known as Supervisor. So we're going to go ahead and cd into etc Supervisor. And just like the Nginx stuff, Supervisor was installed. We verified it with the EC2 instance, but we also did it in the Bootstrap script. So Supervisor has been installed for us as one of those. So inside of Supervisor, this time, there's not as many things in here, so we can actually go into cd into conf d. What we should see is nothing, right? So there's no processes that Supervisor D is currently controlling because we didn't add any, and we didn't install anything that added any, right? So I'm going to go ahead and just do sudo and say myjupyter.conf. Or sorry, sudo nano myjupyter.conf. And this is going to be the name of my process. You can call it a program, and you would just say my Jupyter. and then we add in some configuration. Now, you can absolutely copy and paste, but in this case, I'm going to go ahead and talk about each thing. User is my Ubuntu user, right? So it's the user I've been logged in. It's what I logged in here. If you were using a EC2 instance, the AMI that I mentioned before, you would say something like EC2 user, like that. But in my case, it's an Ubuntu user, so that's the user I want. The directory, as in where do I want this to be called? Now, with Jupyter Notebooks, we can call it pretty much anywhere on our system. So I'm going to put it in the root of this user's folder, right? So that's the root user folder. I'll show you where that is in just a moment. And then the command you want to call for that, and that's Jupyter Notebook, right? So I want the supervisor to always call this command. And when do I want it to happen? Well, I want to have it on auto start, and I want to also have it on auto restart. So if something fails, it will automatically restart. And then I can add in some log stuff, which I will just copy and paste. So if you wanted to have logs for what's going on here, this is how you go and do that. So I'm going to go ahead and save this with Control X, Y to save, Enter to write, and then we list everything out. And what do you know? There's my supervisor actual configuration file. I'm also going to go ahead and make sure that I have that log folder created. I don't know if I actually have to do that, but I like to do it just to ensure that, yeah, my log folder's there. So the logs that I create, or the logs that Jupyter's creating from this process, is for sure there, right? So I put that folder there as a custom one, right? So this name is arbitrary. I just named it that. The next thing is to do sudo supervisor CTL status. So if we see that status, nothing's running. So I can use sudo systemctl, the daemon reload, and then I would do sudo supervisor CTL reread. So this is allowing supervisor CTL to find that process. And what do you know? It says it's available. And then we go into that status, still no status. So then I press up one more time and say update, hit enter, and it added this process to the group. Now I hit status, it says that it's running. So I can stop it with just stop and then the name of it. So it's my Jupyter. That will stop that process from running. I'm not actually going to do that. It's just nice to know that those things are there. You can also use status my Jupyter as well. So you can get the specific status for the specific program that you're running. And in this case, I've got Jupyter running. Notice that my server, I don't have it running on my server at all. So going back into my IP address, it already booted up for me. I used that password I created a while ago, and I use it to actually log in. Now that's pretty sweet. We now have Supervisor running our Jupyter Notebook so we can access it at any time, and it's running in the background. But there's still a problem, and we need to address when we shut down our instance. So one of the things that happened was I accidentally terminated my EC2 instance when I meant to stop it. So this happened off video, and that termination did a couple things. One of them being that, hey, I should make a backup of this instance in the way of an AMI myself. So AMIs are really nice because we can take the state of the instance. So whatever's going on, all the configuration, all of that stuff, we can create an image from it. And this image will be our Jupyter, let's say, launch AMI. And it's really just our Jupyter Notebook launcher. Now, I might need to delete this one in the future. I might need to change it. But the nice thing about this is I can create a backup AMI. So if I accidentally terminate one of my AMIs or one of my instances, I can just relaunch it. Right? So I already have one here. I can hit launch, and then I can go through and configure the details if needed, you know, the VPC and all that. I shouldn't have to do my bootstrap script again, which we'll take a look at that in a little bit. But for now, what I want to do is go into my running instance. I'm thinking that you already have a running instance. And I'm going to go ahead and do the action. I'm going to go to instance state and stop. So we'll go ahead and say yes, stop. While this is stopping, we want to take a look at our IP address. So this IP address is, well, it's ephemeral, so it will actually go away. This is auto-assigned every time you start an instance, and it will go away when you stop it. So what we need to do is set up something called an elastic IP. So we're going to go ahead and allocate a new address here, and this is the name of it. And this address we will add to that instance, right? So it's currently stopped, but before I even associate it, let's go back and take a look. And I see that that IP address is gone, right? Which obviously creates problems if I want to re-log in to that instance. It creates other problems with my configuration that I'll have to address as well. So let's go back into my elastic IPs. I'll go into associate this to that instance. I'll have it in my private IP, and I'll allow elastic IP to reassociate if it's already attached. So in other words, if I already had this elastic IP address associated somewhere, just reassociate it. I'll go ahead and say associate, and there we go. So now that it's associated, I look back on my instances, I looked at my stopped one, it stopped, and yet it still has an IP address. So that means that I can start it back up, and it will start with that exact same IP address. That's pretty cool. That makes things a little bit easier for our configuration. So of course that configuration was mostly in reference to how we have our Jupyter server set up, the actual origin for our Jupyter setup. So you can allow any origin here, which means that it's open to potential problems, right? So it's opening up, allowing any origin to do a request to our server is a potential problem. It might not be a problem, but the philosophy of everything goes wrong always is something that AWS believes in. And the fact that, hey, this might actually be a problem in the future if you don't do this allowed origin, right? Just keep that in mind. So as this is booting back up, I'm going to pause it for a moment and then we'll take a look. Right, so it's running now, and it took a few minutes to actually make that go. So I'm going to go ahead and copy that now elastic IP address, and we'll go to that, and we'll go ahead and log in. Now keep in mind, my EC2 instance may or may not be that quick because we didn't give it that many resources. Like we didn't give it very much memory or CPUs. So I'm going to go ahead and try and create a new Python notebook, and I'm getting this error of not found. Now, there's a couple of reasons for this that we need to address. One of them being my actual configuration doesn't have this as a valid IP. So let's go back into our terminal, and I'll do nanoconnect.sh, and I'm going to change whatever my IP address there is to my new one, and we'll save it. And then we'll go ahead and connect in, and we'll say yes. And now what I need to do is update my Jupyter configuration file, which is referenced on our documentation, but we can just go into cd//.jupyter and list out. And here we will see this Jupyter notebook config. So I'll nano into that. And we've got the incorrect origin here, right? So what I'm actually going to do is let's go ahead and just put star for all. We're allowing all origins here. So we cd into the root. And now that I made changes to my Jupyter notebook settings, what I have to do is sudo supervisor ctl reread, and then sudo supervisor ctl update, and then restart. And of course, in my case, it's restarting my_Jupyter, or I can restart the entire thing. So that with that restart process, if I refresh in here, let's go ahead and log out of this Jupyter, and we'll log back in. Of course, we use that password we created a long time ago. I go ahead and create a new Python notebook, or Python 3 notebook, and just call it hello world. And we can, run the actual Jupyter notebook with hello world and shift enter to execute that. And what do you know? It says hello world. Okay, cool. So if I close this out and I have this Python notebook, let's go ahead and shut that down. And I'm going to go ahead and go back into my server. And I'm going to nano into the config here, which shortcut is tilde/nano Jupyter and then Jupyter Pi notebook config. And if I change this origin, let's just comment it out, save it, and then restart the service again. Started and restarted. I'd go ahead and try to create a new notebook. It says not found, right? So that's a critical error. And of course, if I actually open up the notebook I created, I get a kernel error, right? And that has everything to do with that allowed origin. So it can be a security concern to have it allow any origin, but more than likely you'd want to have your public IP here. But this is in lieu of what we're about to do, right? So the reason I'm leaving it like this is because of what we'll do in just a moment in reusing this AMI. As it stands right now, this is highly, highly reusable. So let's go ahead and hit Control X, Y, Enter to save all of those changes. And then again, we want to restart our supervisor CTL. Let's just double check to make sure everything's running correctly. And we can create a new notebook and all that. I just want to make sure that Jupyter is working. It appears to be, right? Print again. And sure enough, it is. So I can close and halt each one of these. And then I'm going to just delete the untitled one. Great. Okay, so now that we have this, it should be very reusable in the way of an AMI. So let's give that a shot. So I believe that my EC2 instance is now reusable in the way that I can create a snapshot of that instance, as in an image that I can reuse over and over again with a different configuration. So let's try that out. Inside of my running instance, I'm going to go into Actions, Image, Create Image, and this will be the Jupyter Deploy AMI. Okay, so Jupyter Deploy AMI, and this should be the easy to deploy Jupyter Notebook AMI. Okay, so by default, I'm just going to leave that 8 gig SSD. You can change it as you want. But I'm going to go ahead and create this image. I hit close, and I'm going to let that run. While that's running, I'm going to go ahead and delete my old images. I do not need them anymore, so I'll deregister them. It's just not necessary for me to keep ones that I don't need and also ones that may confuse me into relaunching this, right? It might be a good idea to wait for the new AMI to be created prior to deleting the old ones. But we have that guide there for a reason, so you could go back and recreate it if you need it. So if we look back, we could always create more than one too. And I did leave this no reboot unchecked. That's on purpose. We don't need to have that no reboot on there because I do want to allow them to be able to reboot these instances. That's a critical piece. And if we look back into the actual guide itself, Supervisor auto restarts. So if it breaks down or it needs to start back up again, Supervisor, the Jupyter program itself, will restart. Nginx will run as well. Pretty cool. So I'll let this finish. So here we go. We now have our AMI. It's ready to be launched, which means that I can configure my EC2 instance or many instances to have different capabilities associated to them. So let's go ahead and launch one and see what I mean by that. Right, so I can change how it's already configured. I could go up to small, right, so twice the amount of memory, or I could go up to extra large, or I could keep going and get into one of the GPU ones. There's all sorts of types of instances that you can release here. And since we have that AMI, I can actually now go through it. So let's go ahead and just make it. You can stick with micro. I'm going to just go a little bit faster with small. I'm going to go ahead and configure it, use that same VPC I've been using. I shouldn't have to add in the Bootstrap scripts at this point because it's already done. Everything about that instance should be already in here. Next, storage, I'll leave at 8 gigs. Tags, I'm not going to change. Security groups, now I would select an existing one, which was my Jupyter security group. I hit review and launch. We launch it. I still have that key pair, so I'm just going to go ahead and acknowledge that. And I'm going to launch this instance. I go into view instances. Now, of course, the one that I just created is t2.small. It's obviously very similar to the t2.micro or that other instance, but the main difference is it's a different instance type and it's not using that static IP address, right? So if I shut this one down and then restart it, the IP address will change. Of course, I could reassign that IP address if I wanted to, but the point is here is not about the IP addresses, it's much more about the AMI image itself. Notice that it's running, it's going to initialize. It will take a little bit of time for that to finish, but I'm going to go ahead and copy that IP address and go to it right now. At least have it up and running as it initializes. So I'll let that finish. So it finished, it's running now, status checks are done. Of course, that IP address is not a elastic IP address, so it will go away if we shut it down. But we can go into that URL, and sure enough, I can log in to my Jupyter notebook. I mean, to me, that's pretty awesome. We now have a way to easily and effectively launch a Jupyter instance on any size EC2, and we can do it over and over again. So say, for instance, you're running a really long process in one of your notebooks and you still need Jupyter, you could just pop a new instance out, right? And using that same AMI, just like I did. I mean, it'll take a few minutes to provision and actually to start running, but a few minutes while another process is running, that's really, really cool. And it might be really useful instead of having multiple notebooks running on one server, which might take up too much of the bandwidth of that single instance, right? So like if you ran a process in one of these that was taking up 1 gig of memory, which is really possible on this instance, it could take up that entire instance's memory, and therefore you wouldn't want to have another notebook running here. Instead, you could just pop open a new instance, potentially with the same actual memory or the same setup as far as your configuration for the EC2 is concerned. You could have that exact same thing and run yet another EC2 instance for your Jupyter notebook. I think that's really, really cool, and it's also really easy to do. Now, you could make things a lot more complicated in the sense that you do notice that I have this IPython notebook here, right? This is not the same one. It's not the same file, the same exact file of the original one that we created. It's a copy of that file. If it was the same, that would be pretty cool, but that's more configuration than what's necessary for what we're doing here. There's a few ways on how you could go about making those things the same. One of them being storing all of these notebooks in an S3 bucket and then having that S3 bucket synced to your EC2 instance, which is something we're not going to do right now. Another thing you could do is you could use a Elastic Block Store volume that would be attached to multiple EC2 instances. Now, again, that's more advanced stuff than what we really need, because all I really wanted the ability to do was to launch instances on demand and have my Jupyter running and going at any time, right? So there is another configuration that I would probably want to do if I was going to be doing deep learning, which is installing CUDA and all of the things related to a GPU and making sure that that is in the AMI. So this AMI right here is realistically a non-GPU AMI. So perhaps I change the description to be that, or I just make a brand new AMI from one of my currently running instances and just call it, my Jupyter non-GPU instance, or rather AMI, not instance because it's actually an AMI. And same thing, right? Create that brand new, and you can do this as many times as you need. It's really cool. Like really, really useful for reusing your actual setup without having to go through that whole process over and over again, which is yet another reason to understand everything that you do. That's another reason to understand from the absolute 0 to here. That's why we needed to go through all that, is because then I can make changes as I need for any given instance, and I can run, I think it's up to 100 instances for this, although you might remember our subnet can only allow for up to 11, right? So how our subnet is currently set up is only allowed to 11. So if you had 11 and you reached that maximum, you would just need to create a new subnet. It's not a big deal, but it's something that you would have to do. And it's something to consider as you use these things. Now, another thing to consider and probably to do is to either terminate these instances or stop them. I'm going to go ahead and terminate them. I no longer need them. I'm not using them right now. My AMIs, though, I have my non-GPU AMI that's running. I can leave these in here and just redeploy those instances when I need. My Elastic IP, you do get charged for this. I don't think it's very much, but you do get charged to have an Elastic IP. That's another thing that I'm going to go ahead and disassociate and then finally release it. I no longer need that address. But now we have our terminated EC2 instances, but we have our 2 AMIs. I don't need 2, I just need 1. So I'll go ahead and deregister this deploy AMI, and that removes it. Cool. So again, this is private, so only I have access to this. I could share it with other people. You could share it with other people is the point there. And it just allows for just a very effective way of launching your Jupyter notebooks. Hopefully you got a lot out of this. Please let me know in the comments if there's something that you don't think I covered that I really need to, and that's something we can do in a future video. Thanks so much for watching. We'll see you next time.